Hello and welcome to the Auto Digest. I'm James Wyatt. Thanks for joining us today on the program. We are here once again at Precision Automotive and Transmission, and of course with our old friend, James McNeal.
James, good to see you, buddy.
Good to see you too, sir. Well, as we've stopped by today, I see you've added some new decor to the lobby here. We've got a nice big Paris News Reader's Choice Award for 2016. Congratulations on that. And, you know, and one of the things I wanted to bring up today is this goes part and parcel with what you guys are always doing, which is in order to maintain that kind of quality, you're always training, you're always improving, always getting into the latest equipment and diagnostic tools. In fact, here just a few days ago, I stopped by the shop, pulled on the door, and it was locked. And it said, "We are closed for training." And you guys were closed like for 4 or 5 days up in Kansas City or something like that. Tell me about where you guys were at.
We were in Kansas City, and we attended the Vision High Tech training. And this is the 3rd time that we've sent our technicians to it. And we sent 6 technicians to it. And real excited about the classes that we went to. And alluding to the Reader's Choice, I want to thank all of our great clients for voting us number 1. And you know, J.D. Powers for the last 2 years have, the consumers have said to their survey that they trust the independent shops over the dealers. And so we're real proud of that. We're an independent shop, and we want to continue being a good service to our customers and fixing their cars well and keep that going.
Well, and the one thing that makes that possible, of course, is being there on the cutting edge of technology, making sure that you guys are involved in all of the latest diagnostic equipment, all the latest tools. And, you know, you've had an opportunity to show us several things on several different shows in the past. Tell me a little bit about some of the classes and some of the things that you guys learned in this last training session.
They have some neat classes all the way from, you know, how to do brake jobs that don't squeal to how to fix a car with no codes in the computer, and you know, the customer has a complaint, but there's no data, and so you're able to learn the tricks to go in there and find little bits of information to help you get the car fixed, even though you don't have a lot to go on.
Well, some fantastic things, of course, come out of all of this training, and you are the big benefit of that, the customer out there, because it allows you to operate more efficiently, be more cost-effective, and give the customer a better product in the end. Now, one of the things that we were going to talk about today is something that kind of looks familiar to me, but this is really, as we were talking before we went on the air, this is kind of becoming obsolete. So tell me what we've got.
This piece of equipment here is a voltmeter. It's been around for decades.
So it's not unlike something that someone might have in their home as far as a voltmeter is concerned, or in their own shop.
It's really a lot like it. I mean, you know, it definitely, electricians use voltmeters a lot. This one is specifically for automotive. The big reason that this is becoming obsolete very quickly is the cars, the computers on the cars, the information is processed a lot faster, and so we need something that can sample has a faster sample rate, where that it can, like a good analogy with this looks at, in 1 second it will take a sample rate of less than 100.
Okay. And
the scope that we're going to use today, the spec on it is 6 million per second, and so we're talking about in the millions per second sample rate versus less than 100. So
as the cars get packed with more and more technology, basically we have to come up with better diagnostic procedures in order to fix the cars.
Right. Well, what's cool about it is they've come up with better diagnostic equipment, which a byproduct of the scope, which has a faster sample rate, is we're actually coming up with new diagnostic procedures, and we're going to give you a demonstration of that today. One of the things that's a very common thing in the car diagnostics is an engine with low compression. In the past, we would have to pull your plugs out and hook various mechanical gauges up to your motor to decide if you have low compression on one of the cylinders. Today, with our scope, because of the very, very, very fast sampling rate, we're going to hook up to the ALDL connector, which is basically just hooking into the 12-volt system of the car, and then the scope is actually going to watch the electricity mirror up and down off of the starter motor. And we're going to be able to do a relative compression test just off of sampling the 12-volt signal of the car.
And you were saying earlier that basically you can do all of this without even popping the hood.
We won't even have to pop the hood.
Wow.
And also, there's many, many tests that the scope will do. Another one that's been around for a little while, but it's very neat, is a fuel pump test. And so with a lot of cars today, you pop the hood, there's no service port for the fuel pump. So it's like, okay, we think we've got a bad fuel pump, but do we or do we not? And so we're going to be working on a Ford Mustang today.
Okay.
And I look forward to y'all getting to see some of the new diagnostic procedures that are coming out.
Fantastic. So stay with us right here on the Auto Digest. Hi, we're here at Precision Automotive and Transmission, and we're talking with Aaron. You guys have a lot of great programs for folks that may need a little help with that car repair bill.
Not only do we accept payments such as cash, checks, and credit cards, even the majors such as Discover and American Express, but we have special options to where you can go through and finance up to 12 months or as little as 3 months. And it's huge because you don't have to pay so much money down. It's as little as 25% versus the full amount.
Taking care of your car and pocketbook. Precision Automotive. Well, now tell us exactly what we're going to do and what we've got here.
All right, what we've got, basically what we're going to do is anytime you have a misfire, there are 3 components. You need fuel, fire, and compression.
Right.
And one of the things that they had taught us around going about to find your compression was instead of popping the hood and pulling each spark plug out, and a lot of times some of them you can't get to the spark plugs, so it's a really big undertaking to pull the motor apart just to check compression.
Check it out, yeah.
Right.
Exactly.
So they showed us this new way to be able to check it from the data link connector. And the data link connector is where you hook your scanner up. It's where you get your codes and information from the vehicle. So to be able to get that kind of information from that, I thought was, when I was taking the class, was kind of a little far-fetched. But as they went through and walked us through it and showed us how to do it, I was like, awesome. I've got to try this.
Now, one thing about this too, Neal, and something for our customers out there to keep in mind, is this kind of technology really makes the whole process that much more efficient, because if you're not spending the time under the hood pulling out these spark plugs and checking something that may or may not work, basically you're going to spend 10 minutes with the car checking it with this scope, then it makes the cost much less. And it makes your time much more efficient.
Yes,
and that translates into a better deal for you all the way around. So that's just something to keep in mind. So a lot of people say, well, that's great, but why do we do it, or why do we need it? Number one, time is money. It's your money. It's our money. It's one of those things that we all need to be aware of, that basically every time we can save you some time, we're saving you some money. So there we go.
And we're real aware that a lot of people don't have more than one vehicle. One car is their main source of transportation. And
good point.
If the less time it can spend in the shop, the better. So the faster we can get it in, get to the bottom of the problem, and get it back to the customer, it's always better all the way around.
Absolutely. So what's our first step?
Well, we've got a couple of things here. What we've got is, as James kind of touched on earlier, voltmeters are kind of being phased out. They have their place, but really it's not
in the automotive industry anymore.
Right. I mean, there's people that still use them, but there's a lot of stuff that they're outdated.
And he was explaining to me that basically with a voltmeter, what you're looking at is sampling that's about 100 per second.
Right.
Where we're looking at something that is 6 million times
6 million times per second. So with a voltmeter, when you hook it up to a battery, it depends on the quality of the meter, the brand of the meter, they all kind of vary, but the most is going to be around 100 times per second. So it means every 100th of a second it's going to sample, it's going to check. Well, something could happen between here and here. Well, that voltmeter is not fast enough to catch it, and that's where your scope comes in. And with a voltmeter too, is it's just it's a display. It tells you what the voltage is. If it drops and the voltmeter doesn't catch it, you're not going to see it. Because the sampling rate is not fast enough. And also, if you're not paying attention, if you look off and look back at the meter and it changed and you didn't see it. So with the scope, you actually sample, you can zoom in a lot tighter and get a lot better picture of what you're looking at. And you can also map it out, so when the voltage drops or if it spikes or if it does something crazy, you can actually see it.
Okay. Very good.
So,
Well, our patient today looks like a Ford Mustang.
Ford Mustang.
Yeah. Now, what year model is this?
I'm not sure.
Okay. Looks like a fairly late model Ford Mustang.
Late model.
That's something you'd see on the road every day. And
Right.
what we're going to do is we're going to plug into the data link. So the data link is, most cars, is located right under the dashboard,
Yes.
correct?
On 96 and newer vehicles, it was government mandated that the data link connector has to be within 18 inches of the steering wheel.
Okay.
So if you ever need to find yours for whatever reason, it's going to be 18 inches from the steering wheel.
All right, great. So get your ruler out and check that out. Okay.
So what we're going to do is we're going to take this box, we're going to plug this in, okay? And what this
Okay.
is going to let us know, this is a, it's made by AES Wave.
All right, so it all lit up there.
It all lit up. What this is actually a breakout box. What it does is each pin, each wire on the data link connector serves a certain purpose.
Okay.
You've got powers, you've got grounds, you've got communication lines, and what this does is this plugs into that, and it actually lets us, instead of having to try to poke terminals in there or poke test leads in there and mess the terminals up, we can actually hook test leads to this box.
Oh, great.
So we don't damage the data link connector, and it gives us a little extra room here, so just real handy.
Fantastic. All right.
All right.
So we're all set with step one there.
We're all set with step one. All right, so now we're going to get our scope and the test leads hooked up. These are going to connect directly from our breakout box into our scope.
Okay.
So what we're going to do is we're going to hook this up to our scope.
And remember, keep in mind on this too, we're doing the entire procedure here without popping the hood. We're not going to pop the hood once on this Ford Mustang, and we're going to find out what's going on. So I just think that's amazing.
Like I said, this is broke out, so we're going to look. We've got 2 grounds, and we've got a battery voltage.
Okay.
So we're going to take our red lead, which is for power. We're going to go to battery,
Okay.
and then either one of these, they both go to ground. So we're going to go there.
Awesome.
All right. So now we've got that set up.
Okay.
So now we're actually going to go into the scope meter, the scope part of the unit. What we're looking at right now, this is just it's just battery voltage is what we're looking at. Okay.
I don't know why, but I expected to see a heartbeat on there when that came out. Not yet, though.
Not yet. Not yet.
All right.
All right. So if we get it moved around here real quick, make
Okay.
things easier to see. All right. So right now you can see we're just looking at battery voltage. Okay. So what we're going to have to do is we're going to have to couple this to AC. Okay. And what that's going to do is internally within the scope, it's going to run the voltage through a capacitor. Okay. And it's going to change the way that the scope sees the voltage.
All right.
All right. So DC voltage is direct. It
Direct
does not
current.
change. Direct
I
current.
remember that from science class.
Right.
All right.
AC voltage is alternating.
Right.
Okay. So when we couple this, we want to couple it to AC because we want to see anytime the voltage changes.
Okay.
Okay. So we're going to have an option down here in the bottom. So we're going to come down here. We're going to couple it to AC. All right. So right now you can see we have got. It's actually showing 0 volts. Okay. And that's because there's no change in the voltage. Our voltage is at a steady 12 volts. Nothing's changing. So we're showing 0 volts because we're showing 0 change. So we have 0 change in voltage. Okay. So now we're going to change our scale to get everything zoomed in to where we can see what's going on. All right.
This zooming in capability is part of the analyzing of 6 million times per second.
Yes.
Because you're able to zoom in, basically.
Yes.
The analogy that we were discussing earlier that might make this easy to understand, it's the difference between a regular camera running at regular speed right now and then a camera running in slow motion. And you can see so much more detail, and the action slows down, so you're able to actually pick out what goes on. So slow-mo deal, like you would see maybe in a football game, somebody catching the football.
Exactly.
And, was his foot down, was he in, was he out? Well, you can, back it up, slow-mo it, and you can really find out. So that's an analogy to keep in mind for this. All right.
All right. So now what we're going to do is we're going to spin the car over. Okay.
We have some movement here.
We have some blips.
Yep, we had some
All
blips.
right. So now what we're going to do is we're going to stop it.
Okay.
We're going to zoom her in and we're going to look at her. All right. Now it kind of looks like what do they call those, cardiograms?
Yes, it does, yeah. I had one of those not too long ago, as a matter of fact, so it does.
All right, so what we're looking at is we're looking for changes in voltage.
Okay.
The way this works is anytime the voltage changes, this is going to pick it up.
Okay.
Okay.
And that's going to be shown in a variation as far as the
Right, it's going to be shown in a variation.
Okay.
What happens is when you spin the motor over, every time your cylinder comes up on a compression stroke, there is resistance because of the compression.
Okay.
Well, what has to happen is when your starter has to push it through that compression, your amperage is going to increase. So as the compression increases, the amperage is going to increase because the piston has to overcome the compression. So the starter has to push it through it. Well, anytime amperage increases, voltage decreases.
Right.
Okay, so what we're looking at is every time there's a compression stroke, we're looking at a drop in voltage.
So basically, I mean, and this is very simplistic so I can understand it, basically that's if it has to work harder, we're going to see it.
Right, right.
So it's having to work harder so we know that there's a problem.
Right.
Okay.
So anytime we see, so what we're going to look at is we're going to look for drops and consistency. We'll just pick any line. So we're going to go right there. All right, we know this is a V6 Mustang, so we're going to have 6 cylinders of compression, 6 cycles of compression, and then it's going to start over.
Right.
Okay. So we're going to look. We're going to say, all right, that is our first drop. So we've got 1 drop there. We've got 2 drops, 3 drops, 4 drops, 5 drops, and then we've got nothing. So we've got something missing right there.
Okay.
Okay. And if we look, if we want to say, all right, is it repeat?
Right.
So we'll look and we'll come back. We can come back to here and we'll say, all right, we've got 1 drop there, 2 drops, 3 drops, 4 drops, 5 drops, nothing.
Nothing. Huh.
And then we repeat.
And you can really see the difference here too with the wideness of that particular spot right there.
Right.
Okay.
So what we're looking at is we have got 1 cylinder that has low compression.
Okay.
So
Now, what would just so that someone would know, what would if you were driving this vehicle with a cylinder with low compression, what would you experience?
misfires,
Okay.
rough idle, possible check engine light. Just depends on the severity of the cylinder. They give you a spec, and it's going to be used to back in the old days. They would say we need a minimum of 120 psi and a maximum of 130.
Right.
Well, now the way they do it is they'll say we need all cylinders to be within 25% of each other. So they really don't even necessarily give you a definite number because they know that these cars are lasting a lot longer. The compression's gradually going to come down. Valves are going to get kind of crudted up. They're not going to seal right. Rings are going to get worn. Cams are going to wear down. So there's really not a big a spec, but what
So now you have a suspect area basically that when you do get ready to pop the hood, you know where to go.
Right. So for instance, when a customer comes in with this one, they bring it in. They say the cars are running rough.
Right.
So without popping the hood, I do this test and I know we've got a mechanical problem with the vehicle, whether it's rings, whether it's valves, whether it's camshaft. That lets us know right away without popping the hood that, hey, we've got a mechanical problem. We know that a fuel injector and a tune-up's not going to fix this car.
Right. And what's important to keep in mind there is basically this test takes about 10 minutes to do. So you're in, you get a 10-minute diagnostic, and then from there, basically you guys can give them an estimate on, say, okay, well, it looks like you got a problem with the cylinder. This is a job that's probably going to require us to do X number of hours on this. So you have a real good idea within 10 minutes of what you want to do next. Do I want to get this taken care of today? Do I need to schedule a time to come back? Is the car safe to drive? Is it going to leave me stranded on the road? So for 10 minutes worth of your time, you can have a great amount of information to work with so you can plan your next car repair. So that's really, really important.
Right.
All right, great. So what's our next step?
Our next step is what we're going to need to do
Fix
is fix it. Yes.
Okay. When we come back, we'll have the fuel pump next hooked up to our scope here on the Auto Digest. So don't go away.
Test your battery free at Precision Automotive and Transmission. And should you need a new one, vented batteries are just $89 installed with national warranty. An ASE certified technician will get you back on the road quickly. All this and 24/7 roadside assistance protecting you for 12 full months. You're in good hands with Precision Automotive and Transmission, 2675 North Main, Paris, Texas.
we're going to continue now. We are looking at a new scope that they have here at Precision Automotive and Transmission, which is absolutely just fantastic. It's designed to save you money. It's designed to be more efficient. And what we're going to look at now is the fuel pump. Now, we did have to pop the hood for this, though.
We did have to pop the hood for
Okay.
this one.
So tell me what we're going to see.
Okay, what we're going to look at now is the actual condition of the fuel pump itself. Without looking at each individual armature and looking at the brushes, and without physically taking the pump out and taking it apart, we can actually check it and inspect the condition of the pump without pulling the pump out. So,
Now, what kind of problems would somebody be experiencing if they were having fuel pump problems?
they
So
could
if somebody's
have
driving around out there and you go, hey, that's me.
reduced power.
Okay.
Maybe the car's a little hard to start.
Okay.
Check engine light,
Okay.
lean codes because we're not getting enough fuel up to the motor. Lots of different.
Okay. So it could be the culprit in lots of different things, but if you have had one of these problems that you think, well, gee, the car's not running like it should, or check engine light keeps coming on. I know the thing that probably is most striking to most people, you run out, you jump in the car in the morning, and you're trying to start the car in the morning, and it's Could that be a fuel pump issue?
Definitely.
All right, so that's something that could easily be you out there. Within 10 minutes, you can come in, have that checked out, and go on down the road and find out a little bit more about what's going on. So let's go ahead and let's go. Our patient is still the Mustang, so we're gonna. This car's got problems, so we're gonna take a look at the fuel pump here.
Right. So what we're going to use on this one is we're going to actually use a current clamp.
Okay.
What this is designed to do is it's actually designed to pick up and measure the current that flows through a wire.
Okay.
So anytime the armature comes by the brushes, the current's going to increase because it's going to push the pump, it's going to push the fuel, it's going to pressurize the system. So what we're going to be able to actually do is look at it and see what's it look like, what do the brushes look like. 'Cause if we've got worn brushes, we're going to see that definitely in the pattern. If we've got a bad armature, we're definitely going to see that. If we've got one that's pulling entirely too much amperage, we can see that. If we've got one that's slipping, the impeller on the pump itself that's slipping, we'll see that as well. We're going to need to find our fuel pump relay, which is going to be this one back here. So what we're going to do is we're going to remove the relay.
Okay.
And what we've got here, this is just a jumper lead with a fuse. That way you don't take a chance on damaging anything in the system.
Okay.
And what we're going to do is we're going to go from our voltage supply to the actual current side or the control side of the pump. So what we're going to do is we're going to put our jumper relay in here. And what that's going to do is that's going to allow something for this to read.
I see.
All right. So now we'll
Move this in.
scoot this in over here.
Okay.
All right, we're going to go back into our scope. And this time, instead of volts, we're going to look at amps.
Okay.
All right. We're going to hook our current clamp up,
Okay.
turn it on. We're going to zero it to make sure that we're not getting any bogus information.
And that just goes around that wire.
That just goes around the wire, right.
Okay.
And the way this works is anytime electricity flows, it creates a magnetic field.
Okay.
What this does is this is going to pick up and measure the amount of current or the magnetic field that's being generated
Okay.
as the current flows through the wire. All right, so we're going to hook this up, and we're going to back up, and we're going to go into our scanner side. We're going to come down here to our fuel pump, and we're going to turn it on.
Okay.
We'll turn it on, and then we'll look at it and see what she looks like. All right, so now you can hear the pump running. So now we're going to go right back over here to our scope. We're going to let it sample just a little bit. That way we get a lot of information in here.
And you're able to do this without even starting the car?
Right, without even starting the car.
Wow.
Without starting the car, pulling the pump out, or just a matter of just pull the relay out. All right, so now we've got quite a bit of information. We're going to stop it.
Okay. Take a look at our sample.
We're going to look at our sample. All electric motors use brushes and armatures, and the way they work is as the armature comes along the brush, as it starts making contact, we're going to start increasing our current. So when we've got just a little bit of contact here, our current's going to gradually increase until we made full contact, and at that point we're at the peak of where we've made full contact. Our current is the highest.
Okay.
And as it goes past, our contact is going to reduce and our amperage is going to lower.
Okay.
All right. On 99% of fuel pumps, they have 8 armatures. So that means there's going to be 8 armatures per 1 revolution. So what we will do is we're going to drop our cursors in here.
Okay.
Let's see. We hit the right button. All right. So now we'll come over here. We'll just pick one because we know we've got 8. We know they're going to repeat. So we've got one there.
Okay.
So we've got 1, 2, 3, 4, 5, 6, 7, and 8.
So from there to there is a good sample.
That is 1 revolution of the pump.
Okay.
All right. So what we're going to look for is we're going to look for any spikes where if we've got a shorted pump, the amperage is going to increase because we've got a short. If we've got a bad armature, we're going to have a missing pulse. So there's going to be no amperage in one area. Or if we've got worn brushes, we're going to be able to see the actual. You can actually see the shape of each brush in each armature here.
So if one's a little more worn than
So
another,
if one's a little more,
be able to tell that.
you can
Wow,
actually
that's
see
amazing.
it. You can actually see it. So what we'll do is we'll look and we'll say we've got 1, 2, 3, 4, 5, 6, 7, and we've actually got one that's a little on the downside.
It's the runt of the litter.
It's the runt of the litter, right? And if we would look, if we'd start over, so we'd call that one 1, 2, 3, 4, 5, 6, 7. And there she is again.
Yep.
She kind of.
It does look a little different.
Yeah.
Yep.
And
I
that's
don't know if you can pick that up, but it is. It actually looks a little bit different before it too, just a little bit before it too. So is that indicative of something going on?
It's worn or a worn armature is what that is.
Really?
If we had worn brushes, we would see it. We would see it because we've only got 2 brushes. We've got 8 armatures.
Okay.
So if we had worn brushes, we would see a problem on every single ramp. Whereas this one, we only see it on one, so we know we've got a problem on one ramp.
So
or on one armature.
With this degree of wear, would that create a problem?
Yes.
Okay,
yes,
so you would
because
actually feel that in your vehicle.
it's very possible because when it gets to that spot, what's going to happen is the amperage is going to be lower, and that actually the speed on that section is going to be slower. So it actually, if you had enough, if it was bad enough, it could actually slow down fuel pump speed enough that your fuel pressure would drop. It could give you hard starts. It could give you low power. Lots of different things.
Wow, and that could really affect your driving in a lot of
Yes.
ways too. Would it affect your fuel economy?
Most definitely.
Really? Wow. Okay.
Because the computer, whenever it sees that we're running out of fuel, the computer's going to try to give it more.
Right. Well, what's important to remember here too, folks, once again, able to pull this information out of the vehicle. We set this up in probably less than 5 minutes. You know, once the vehicle's in here, a 10-minute stop here at Precision Automotive and Transmission, you're experiencing some problems, and we can get a quick diagnostic for you and find out exactly what's going on, and then you can make an informed decision about what you want to do, because this is only going to get worse.
Yes.
So it's not going to fix itself. Some people have that theory. Well, I'll just drive it till it fixes itself. That doesn't happen. So you need
If
to
that
come
happened, we'd be out of jobs.
Yeah, absolutely. You need to come in and get that checked out. This is really a great piece of technology. One of the few shops that you're going to find probably within a 200-mile radius that's going to have all the equipment that these guys have. So just fantastic. Great job. Well, I tell you what, we're going to wrap things up here in just a few moments. We're going to bring James back in, and we'll be back with a quick word right here on Auto Digest after this.
My name is Lori Russell, and I've been a Precision customer for 3 years. Precision Automotive always takes great care of me and my vehicle. We recently went on a family vacation. However, before we left, we stopped by Precision. They checked on our tires. They found an issue with one of our tires that would have left us stranded on the side of the road. Precision Automotive always takes great care of my car and my family. Precision Automotive, I highly recommend them, and I would never go anywhere else.
Well, we're back here at the Auto Digest at Precision Automotive and Transmission, and James McNeal has joined us once again back here in the shop. And James, I've really been impressed with what Neal's been able to show me. I mean, it was like doing magic on this car. We didn't even pop the hood, and he found out what problems were, attached a couple of wires, and we are geared to go. We got a plan to fix this vehicle now.
I'll tell you, I'm very proud to have Neal here. Neal is a ASE master technician. We have 4 here, and he's one of them. And as you can tell from what you saw today, he definitely knows what he's doing. And that's one of the things that we try to do here. We try to repair things. We don't try to just replace parts and see if that fixes it. We want to know what the problem is. And that saves the customer money. That helps everybody. So
Well,
real proud to have Neal here.
That was one of the things we were talking about. All of this is designed to save time, which in the long run saves you money. And that's what we're all about, to give you the best quality repair at the very best price.
That's right. We appreciate y'all coming and
Absolutely.
visiting with us a little bit.
Well, Neal, James, thanks once again for joining us here on the Auto Digest, and thank you so much for being a part of the program. We always appreciate you out there. And remember, anytime you've got questions, even if it's just a question about something we've talked about on one of the shows or something that you've got going on, these guys are a wealth of information, and they're always glad to help. So stop by the shop here and find out what helps keep you going down the road safely and securely here at Precision Automotive and Transmission. Thanks for joining us.
Thanks for watching.